Hello viewers, you are welcome to T-Ben Math class. In today's lesson, we're going to look at scalar multiplication of matrices. Scalar multiplication of matrices. Let's look at what we have on the board. If A is equal to, that is matrix A is equal to A, B, C, D, then K being the scalar, the K there is the scalar. The scalar can be a fraction, a whole number, a negative number, or a positive number. So Ka means that we are going to multiply K by the matrix A. And how is it done? This is done by multiplying the scalar by each of the elements of the matrix or in the matrix. So here, K will be multiplied by A, K by B, K by C, K by D. So we have Ka, Kb, Kc, Kd. Also, if P is equal to A, B, C, D, E, F, this is a 3 by 2 matrix. 3 rows, 2 columns. If a scalar is to be multiplied by the matrix here, the same thing will be done. The K will be multiplied by the matrix given, and the K will be multiplied by each of the elements of the matrix. So we have Ka, which is Ka, K by B, Kb, K by C, Kc, K by D, Kd, K by E, Ke, K by F, Kf. So that is how a scalar is multiplied by a matrix. Now let's look at our first example for today. In the first example, P has been given as 4, -5, 3, 6. Q is 10, 15, 25. And we are to find I, -5P. I, 1 on 5 Q. So let's consider the I. -5P means that our scalar is -5. And the matrix P has been given. So it will be -5 multiplying our matrix 4, -5, 3, 6. And this will be done by multiplying the -5 by each of the elements in the matrix. So here we will have -5 by 4 will be -20. -5 by -5 will be 25. And again will be 4. -5 by 3 will be -15, and the -5 by 6 will be -30. So this will be the answer for the first one, or for the I. So in our second example, we have 1 on 5 Q. So the scalar is 1 on 5. So it will be 1 on 5 multiplying the matrix 10, 15, 25. So we are going to have 1 on 5 multiplying each of them. So 1 on 5 by 10 will be 2. 1 on 5 by 15 will be 3. 1 on 5 multiplying 20 will be 4. And the 1 on 5 multiplying 5 will be 1. So this will be the result for 1 on 5 Q. 1 on 5 multiplying matrix Q. That is the answer, 2, 3, 4, 1. In our example 2, we have given that A, that is matrix A, is equal to 2, -1, 4, -5, 3, 6. And the matrix M, we have been given another matrix. Matrix M is equal to -4A. Find the matrix M. So we have been given an expression for M, and it is said that M is equal to -4A. So it means that in order to obtain the matrix M, we have to multiply a certain scalar, which is -4, by the matrix A given. So in this, we are going to have -4 multiplying the matrix 2, -1, 4, -5, 3, 6. So this will be multiplying negative 2 by each of the elements. So we will multiply negative 4 by 2. And negative 4 by 2 will be negative 8. Negative 4 by negative 1 will be 4. Negative 4 by 4 will be negative 16. Negative 4 by negative 5 will be 20. Negative 4 by 3 will be negative 12. Negative 4 by 6 will be negative 24. So this is the result, or this is the matrix M. Now in our third example for today, we are to find 2a minus 3b plus 4c. If a is this, b is this, and c is that. If we want to get the answer correctly, then what we need to do is that let's do it component by component. So let's pick only 2a, we solve for it. We pick 3b, we solve for it. Then we pick 4c. So let's do that and see. 2a here means that we are multiplying a scalar, which is 2, by matrix A. So we have 2 multiplying matrix A, and it is negative 3, 0, 7, negative 4. So what do we get when it is multiplied? This by this will be negative 6, 2 by 0, 0, 2 by 7, 14, and then 2 by negative 4, negative 8. Now let's pick 3b. 3b 2 means 3 multiplying the matrix B, and we have 2, negative 1, negative 7, 4. So this will be equal to this by this. 2 by 3 will be 6. 3 by negative 1 will be negative 3. 3 by negative 7 will be negative 21. And then 3 by 4 will be 12. So we have obtained 3b. So let's tackle 4c. 4c will also be 4 multiplying the c, which is 1, 0, negative 2, negative 4. So we will have this by this 4, 4 by 0, 0, 4 by negative 2 will be negative 8, 4 by negative 4 will be negative 16. So now that we have obtained the components, let's put them together. So our 2a minus 3b plus 4c will be, the result for 2a was negative 6, 0, 14, negative 8. Minus 3b, we had 6, negative 3, negative 21, 12. Then plus our 4c, we have 4, 0, negative 8, negative 16. So let's simplify everything. So in this, we are going to do it straightforward. Since we know how to do it, we have negative 6 minus 6. And this will give us negative 12 because we are simplifying the corresponding entries. So negative 6 minus 6 will be negative 12 plus the 4. So first. Negative 6 minus 6 plus 4. So negative 6 minus 6 will be negative 12. Plus 4 will be negative 8. So we will have negative 8. Let's write it here. We will have negative 8. And then when we look at the second part, 0 minus negative 3 will be 3. Plus 0 will be the same 3. So we have 3 for it. Then when we come here, 14 minus negative 21. And that will give us 35 plus negative 8. So we have negative 35 here plus negative 8. 14 minus negative 21 will give us 35 plus negative 8 will be 27. Then negative 8 minus 12. Negative 8 minus 12. Second. Negative 8 minus 12 will be negative 20. Plus negative 16 will be negative 36. So we have negative 36. So this is the result for the whole expression here. This is the result. We have negative 8, 3, 27, negative 36. In our fourth example, we are to find the expression 3p plus q minus 1 on 3r, given p, q, and r in the question. So as the third example was dealt with, when something like this is given to you, you can solve this expression by dealing with the components first. So we pick the first component, we solve. So we have the first component to be 3p. 3p means the scalar 3 should be multiplied by the matrix p. So 3, 4, negative 2, 6. So in this, the 3 will be multiplied by each of the elements. So we have 3 by 3 will be 9, 3 by 4 will be 12, 3 by negative 2 will be negative 6, 3 by 6 will be 18. So this is the result. The second part does not have any scalar, so it will be maintained. But the third part, or the third component, has a scalar which is 1 on 3. So let's solve that one too. 1 on 3 r will be 1 on 3 multiplying matrix r, and matrix r is 6, 9, 3, 12. So this will be 1 on 3 by 6 will be 2. 1 on 3 by 9 will be 3. 1 on 3 by 3 will be 1, and then 1 on 3 by 12 will be 4. So this is what we have. It means that now that we have the components, we put everything together, we get the whole expression. So we will have 3p plus q minus 1 on 3r. So this will be, the 3p was obtained as 9, 12, negative 6, 18, plus the q was still q. So we have the q as 4, negative 5, 2, 5. And then our r, that is the component where r is, we had the whole thing as 2, 3, 1, 4. So we are going to simplify everything. Straightforward. First. Second. First. Second. So let's start. 9 plus 4 will be 13. Minus 2 will give us 11. And then 12 plus negative 5 will be 7. Minus 3 will be 4. And then when we come down here, negative 6 plus 2 will be negative 4. Minus 1 will be negative 5. So we have negative 5. And then 18 plus 5 will be 23. Minus 4 will be 19. So this is the result for the whole expression. Before we bring today's lesson to an end, I would like to give you a trial question. The question is on the board. You put the solution at the comment section. If you really found this video or lesson useful, like or subscribe to my channel and like the video as well. We will meet another time for another lesson. Until then, goodbye.